this is Space Talk. I'm going to talk now. I might have done 3 videos or 4 videos now today. I'm going to talk today about galactic collisions. It's going to happen around about 5 billion years from now, maybe a little bit more. Go away, you wayward bag of bomb. Oh, see someone. So probably what you can see on the screen of the screen recorder and me in the webcam, hopefully, is this thing. This thing here. This is Andromeda, and this bit, well, this is just our Milky Way. So it's going like that, and that's the Milky Way. That's the dust lane, one of the spirals on the Milky Way. That thing is in our galaxy. This is the view 2.5 billion years from now, so you won't live to see this. It's that big. This is Andromeda. This thing going like this is Andromeda. That is a supermassive black hole in its core. Every core of it, almost every galaxy we suppose is a supermassive black hole. I'm going to give you a little bit of, okay, nowadays if you look, this is true if you live in America, the Andromeda is about this big and is situated here in the sky. This is 2.5 billion years, so don't believe this when you look into the red sky. I'll come to it a bit later. It's actually around about there. It's about there. And it's about that big. From where I'm moving the thing. But that big. It's tiny, it's a smudge in the sky. It's outside the galaxy. Let's just say that. This is in the galaxy. That is not in the galaxy. That's an entire different galaxy. Same as ours. Jonathan, come in here. We're going to show you how the galaxies will merge. We're going to hit towards me. We're going to hit this, then you go past me. They're going to go round in an endless cycle. Okay? Come back into the video. Jonathan, you don't know anything about it, so you can ask any questions. It's going to spin round. The two cores are going to merge together. Two massive black holes. They're going to spin around each other until they actually merge. It's quite interesting, and it's a lot very powerful. So this core, same as ours, but this is Andromeda's core.
You might not be able to see that, but if
you'll see it on the screen. That core there is the Andromeda's core, and that is a new galaxy. That will hit us in 5 billion years. That's 2.5 billion years from now, and I so want to live. I want to be practically frozen. See that. So want to. But actually, in the sky, it's around about that big in America. And for us, it's directly up. We don't see this very much.
So this is called Milky Way. Where are we?
In the Milky Way? Well, let's say that this was the Milky Way. This is Andromeda, so you can't use this. But let's use this as the Milky Way. We'd be around about. Let's say this is we are on the right side. Let's say we're on the rotation well with the right hand side of it. Around about there. Off from one of the spirals, yeah. We'll be way off. We are nowhere near the core of our galaxy. We are out in the.
So what's in the core of the galaxy?
What?
What's in our core of our galaxy?
Supermassive black hole. That core is always a supermassive black hole eating, swallowing matter. What?
What's near there?
A few planets. They're gas giants, and there are a couple there where we think sustain life, with stars around them, and a lot of stars that are orbiting the black hole. It's very interesting. Actually, quite interesting to know, because we orbit really slowly compared to the core where it orbits really fast. It takes around about a day from completing orbit. It takes us around about 22,000 years. Of the Milky Way. So, but where we think there's a life-sustaining planet that will hit us isn't there. We don't think it will hit us, we think it's going to come into our solar system. There's a star that can also hit us and could theoretically save us by prolonging life. But it's there, so there's a high chance that it's going to miss us. So life from there might come next door neighbour. It orbits really fast compared to us.
So we don't know if there's any life in there yet.
We're not completely sure. We think there's life on there. It's a life-sustaining planet. But, sorry about that. I'm not forgot. The sun's set and the light seems to be dimming, so we'll be going out in a minute now. But yeah, we think it's there, but what we're also worried about, well, a lot of astronomers are worried about, is especially me, the junior ones are, because we've learned how to see very interesting. When we hit, because we're both spiral galaxies, we look like that. That is just an arm of our galaxy. Just might drop the pen, but drop the ball on that one. That is a spiral arm of our galaxy. That is the Milky Way. That's Andromeda. And every star you can see in the sky, except for this is another galaxy, but every other star in the sky is in our galaxy. Everything you can see with the naked eye is in the galaxy. It's in our galaxy. That has 1 trillion stars in it as well. Cool. So then yeah, there's about 9,000 in the Milky Way. We're smaller than that galaxy as well.
So, do we know if there's any living beings in that galaxy yet?
No. We haven't beamed any according to that they've got any. We haven't beamed any recordings that they've got anything back. But we're not sure. For all we know, they're the same as us. We're beaming stuff out now, and so it picks it up, and we're just praying, and like us, they're praying, they pick us up. There's actually a paradox saying that as I'm saying this video, there's someone in that galaxy saying the exact same things as I am at the Milky Way, thinking the same thing as the same person. That's a paradox. We know that's going to hit us because it's a spiral galaxy. We'll become an elliptical galaxy. So when that hits us, we'll become a different galaxy, because we're smaller. We're more likely to lose the tug of the galaxy. And after that, the sky is going to, after I don't know, 3 billion years maybe, the sky will go a different colour, going to like a tie-dye almost, where new stars are forming, galaxies and gases all together. We don't know whether anything's going to hit us. Going back to that, the junior astronomers thing, what we're worried about, ultimately, is that core, and the core of our galaxy, what's going to do to us. There are 2 possible destruction events that can happen. 3 possible. The first one, our core off when we're at an angle, and it hits us, and as our galaxy tethers apart, we're flying off into deep space, never to be heard of from the Milky Way or Andromeda ever again. So the solar system is left in empty nothingness of space to just travel. Which would mean there are stars and especially planets, rogue planets we call them, that go through galaxies, but no one's ever gone in between a galaxy. And anything that goes through there is often incredibly dangerous. There's a lot of gamma radiation, high levels of radiation, and also incredibly high levels of stars that are volatile and debris coming out of galaxies. So going through there would also definitely be a death trap. There'd be a high chance that we wouldn't find another galaxy. Oh, there we find another galaxy. If we did find another galaxy, however, we could very quickly find ourselves very close. Now the second possibility is including that core and the Milky Way's core. We are caught at a good angle, and as Andromeda's gravitational field hits us, we are pushed inwards. Now this is bad news for us, because the cores will push each other against each other. No one wants to be one pulled into the other one. That's what happens, they're pulled into each other. No one wants to be not a single one wants to be pulled into the other one, and that's the benefit about, is that as we get pushed in, we get sucked into the other one's core. We could, along with lots of other stars and lots of other planets and lots of comets and stuff, be pulled in to a death trap and pushed towards one of the black holes, or one of our black holes, and we could have our entire solar system very comfortably eaten up by one of these supermassive monster black holes, which is very, very painful, I can imagine. So I wouldn't want to be that and pushed towards. It depends on really where we are. The third one depends that we're not too far, we're not too close to Andromeda, we're not too far away. We can't be pushed in, pulled up, pushed off, and that is collision. That is collision. What that is we collide with something coming. Now, remember that 1 trillion stars? We have about 900. We have about 90,000 stars in our Milky Way galaxy. You know that. We could quite possibly be pushed in something in there. Not a black hole. Black holes, I already said. Or, more terrifying, star. Or another planet. Know that deep impact, things like that. Imagine that being real and very, very, very dangerous. Deep impact in Armageddon was a comet. This wouldn't be a comet. This would be a planet. We might be able to. The Earth would survive a comet. Its inhabitants would die off. But a planet could destroy the planet. Earth could be destroyed by a planet. So from there, if a planet hits us, you know, the size of planet Pluto, if it hits us, break us apart. Get neutron stars could also do the same thing, pulling things away and shreds us, pulling stuff into a ring around it. Very worst thing though is a star. We can't tell, but we think that every star in there is big, about bigger than our sun. I think the small star is just a little bit smaller than our sun. So, if it's bigger than our sun, it's bigger than everything else out there. Because it's, you fit every planet into the sun a couple of times over. Including Jupiter. It's 2 times over Jupiter. So, something twice the size of Jupiter being swallowed up by something bigger than that. Can you imagine that? It's hard to imagine. I can. I can imagine that all the time. There are small stars, but there are also big stars. But that, the star from there hit us, you wouldn't get much time to run or panic. You'd most likely not realise it. As soon as it ate something, the sun would just seem to get bigger. We just think, what happened? It might save us. The sun might be eaten, keep flowing its life. But what I think it would most likely do is just move straight through. It's on a moving course. It wants to stay past Andromeda and not come far Milky Way. So it'll probably break path into our not come to the Milky Way and try and push back to Andromeda, because that thing circles around to hit us again. They're trying to merge. So we could also we might be spared once. Then we think it's safe from a hit in the back of the head by again. Which one of those do you think you would least likely want to have happen to you? Fall into a black hole, sent to freezing deep space, or hit by a star and then hit on the way in the back of the head by it?
I don't know.
It's up to you. Comment as well which one you'd least likely want to have.
Not freezing to death.
So not freezing to death, that's a good thing.
Or the other option.
Sucked into a black hole, supermassive black hole, or hit by a star.
Supermassive black hole.
You'd least like, so you least likely to be pulled apart in a black hole.
No.
I would guarantee that it's probably roasted, just looking to hit melting instantaneously.
Get hit by one stuff.
Yeah, I'd choose that. That one the I would choose. The one I'd least like to have happen would be falling to a black hole and ripped apart. So I can imagine that that would probably be what we would want that happen. Strangely, we know that's another galaxy because of its shape. Same reason we know that is Saturn. It's like a ring. Why has never no one ever made a Saturn ring wedding? Actually married.
When you're married.
And then like it's just like different colours. Penumbra and umbra. For some reason people keep thinking I'm saying this probably because I say penumbra. Does that seem weird to you?
No.
Yeah, though. Beetlejuice on this would probably be. There's Orion. That's Orion, by the way. Beetlejuice. The new stuff. Quite nice to know that. That's Beetlejuice. That's the new stuff.
Wish we could see tonight.
Yeah, that's the baby star. That's
Which
little,
one?
That's the baby star. That's not a little baby star. That's the one dying.
Which one? That one.
That one's the one dying. That's the little baby star in the right. Kind of sounds weird when I say it out loud, doesn't it? It's a little Orion's nursery. You say it.
It's a little Orion's nursery.
Sounds odd to say that about stars that they go into a nursery. But yeah, it's amazing to be able to look at that and know that that's going to. Like, I wish I could look up in the sky and see that because I want to see it. I can't. So I have to admit that I'm beaten. Oh yeah, that's the Great Triangle. They're very old stars. And they're the newer stars. Where's the AB moving? Sorry everyone, I'm just going to get my bearings. Pleiades? Pisces, I think they're called. That's relatively newy, oldie, youngy. They're somewhere out here. There's an AB moving. I think that's called then. And they're like, the AB moving group is about 120 stars and some rogue planets. You won't see that tonight, by the way. I'm not going to focus on it too much. Somewhere out there, so it's very hard to say, and I wouldn't recommend trying to see it. It's very difficult to mask the way it looks. Quasar. That is very, 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 very old. There. That, everyone, look really hard and squint your eyes. I don't think you're wearing glasses in case you guys so much. No, wait. Yes, squint your eyes. You're wearing proper glasses. Me, I'm wearing proper glasses. There. There. The pulsar. It's not quasar, pulsar. And the difference is a pulsar is both things pulsing, and it's just pointing to the direction. Whereas a quasar kind of pointed near us, but not actually at us in a quasar. We're pointing straight at us. So we get minimum amount of light from a pulsar, but they're very bright. And very, very far away. Same thing for HDE code 1, 2, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, That's Orion. I think that's actually there. Yeah, that's it there. There's a triangle in there, but that's Cygnus. So, where I'm looking for black hole, you might not be able to see this because you're on it's you come up from the tail of the swan, going up the body, just off, there's the bright star, you look up, and it's around up there. There, you'll find a black hole. Cygnus X1.